Welcome, dear explorers, to Earth with Nature, a sanctuary where we unravel the mysteries of our universe with a calm, curious heart. Today we embark on a profound journey, one that takes us not across the stars but deep beneath our very feet, to the hidden realms 4,000 miles below the surface, and beyond that, into the cosmic wonder of what Earth truly represents. Settle in, let your mind wander, and allow the weight of daily life to drift away as we ponder a question that has intrigued scientists and dreamers alike. Is our planet just one of many worlds scattered across the vastness of space? Let's dive straight into this enigma, exploring the layers of our own Earth as a starting point to understanding the grander tapestry of planetary science facts and exoplanet mysteries. Picture this. Beneath the soil, the oceans, and the crust we walk upon lies a world unseen, a molten heart of iron and nickel, a core that pulses with heat and energy, shaping the very magnetic shield that protects us from solar storms. This inner Earth, hidden from our eyes, mirrors the hidden truths of the cosmos, where countless worlds may hold secrets of habitability or desolation. As we peel back these layers, both literal and metaphorical, I invite you to join me in a slow, deliberate exploration of what makes a planet a home, or a graveyard. What do you think lies at the center of our world, not just physically but philosophically? Let's uncover this together, step by step, as we traverse the realms of geology, astronomy, and the fragile balance of life itself. Our journey begins now, with Earth as our guidepost in a universe brimming with possibility, and I'm thrilled to have you along for this immersive ride into the unknown. As we stand on the surface of our blue-green home, it's easy to forget that beneath us lies a realm as alien as any distant star system. Let's journey inward to the center of the Earth, some 4,000 miles below, where temperatures soar to 10,800 degrees Fahrenheit, hotter than the surface of the sun. This is the inner core, a solid sphere of iron and nickel, surrounded by a liquid outer core that churns like a cosmic engine, generating the magnetic field that cocoons us from deadly solar radiation. Imagine this molten dance, a fiery ballet that's been ongoing for billions of years, as the heartbeat of our planet. But what does this tell us about Earth's place in the grand cosmic orchestra? Planetary science facts reveal that Earth is a rarity, a world with a dynamic interior that supports life through tectonic activity, recycling nutrients and maintaining a stable climate. Yet, as we peer into the night sky with telescopes like the Kepler Space Telescope, we've discovered over 5,000 exoplanets, many orbiting in the so-called Goldilocks zone of their stars, where conditions might just be right for liquid water. Could these distant worlds, like Kepler 452b, often dubbed Earth 2.0, harbor molten cores and protective magnetic fields too? Or are they barren, lacking the delicate balance that makes our planet habitable? Reflect for a moment. What makes Earth so special in this vast sea of cosmic wonder? Is it merely chance? Or is there a universal recipe for life that we're only beginning to understand? As we ponder these exoplanet mysteries, let's remember that Earth's hidden depths are not just a geological marvel. They're a clue to decoding whether we're truly alone or part of a sprawling family of worlds. This connection between our planet's fiery heart and the potential for life elsewhere draws us deeper into the science of habitability, a field that bridges the gap between what we know and what we yearn to discover. So, let's keep exploring with open minds and a sense of awe, as we transition from Earth's core to the broader implications of what it means to be a living world in an infinite universe. Now, let's linger on the concept of habitability, a word that carries the weight of life's possibility, yet also its profound fragility. Earth, with its balanced atmosphere of nitrogen and oxygen, its liquid water, and its temperate climate, seems like a perfectly crafted haven. But consider this. Scientists estimate that Earth's habitable conditions might only persist for another billion years or so before the sun's increasing brightness boils away our oceans. This isn't science fiction. It's a stark reminder from planetary science facts that even our resilient world is on borrowed time. Look at Venus, often called Earth's evil twin. Just a little closer to the sun, it once may have had oceans, but a runaway greenhouse effect turned it into a hellscape with surface temperatures hot enough to melt lead. Then there's Mars, a frigid desert with hints of ancient rivers, now a ghost of what might have been. These planetary neighbors frame Earth as a delicate outlier, a reminder of how precise conditions must be for life to flourish. Now, imagine the thousands of exoplanets we've detected, worlds like Proxima Centauri b, orbiting the closest star to our Sun. Could it hold life? Or is it another cautionary tale of lost potential? I ask you to pause and think. How fragile is the balance that sustains us, and how often does the universe get it right? As we delve into exoplanet mysteries, tools like the James Webb Space Telescope are helping us analyze distant atmospheres for biosignatures, traces of gases like methane or oxygen that might hint at life. Each discovery is a piece of the puzzle, but it also humbles us, showing how unique Earth's story might be. This fragility isn't just a scientific observation. It's an emotional anchor, urging us to cherish our home while we search for others. Let's carry this thought forward as we expand our gaze to the philosophical reflections of what finding another habitable world would mean, not just for science, but for humanity's sense of purpose in the cosmic expanse. As we stand at the intersection of science and wonder, let's take a moment to reflect on a deeper question. What does it mean for Earth to be one of many potential worlds, or perhaps the only one of its kind? This isn't just about data or telescopes. It's about our identity in the vastness of space. For centuries, humanity believed Earth was the center of everything, a unique stage for the drama of existence. But with every discovery in astronomy, from Galileo's observations to the Hubble Space Telescope's breathtaking images of distant galaxies, we've been humbled. Today, planetary science facts suggest there could be billions of Earth-like planets in our galaxy alone, based on statistical models from the Kepler mission. Yet, we've found no definitive sign of life beyond our pale blue dot, as Carl Sagan so poetically called it. Does this silence in the cosmos mean we're alone, or are we just not listening in the right way? Picture yourself gazing at the night sky, each star a possible sun with orbiting worlds, some perhaps teeming with life, others silent and cold. How does that make you feel? Are we a cosmic accident, or part of a grand design we can't yet comprehend? These questions, woven into the fabric of exoplanet mysteries, challenge us to rethink our place in the universe. If we do find another habitable world, it could redefine everything: our philosophies, our religions, our very sense of self. But even if we don't, the search itself is a testament to human curiosity, a drive to connect with something beyond ourselves. This emotional and intellectual journey ties us to Earth in a profound way, reminding us that while we search for cosmic kin, we must also protect the only home we know. Let's carry this reflective energy as we move toward the broader implications of our quest, exploring how technology and determination are pushing the boundaries of what we thought possible in the realm of cosmic wonder. The quest to understand Earth's uniqueness and the potential for other worlds is not just a dream. It's a mission fueled by cutting-edge technology and relentless human determination. Let's marvel at the tools that have brought us closer to the stars. The James Webb Space Telescope, launched in 2021, is a masterpiece of engineering, peering into the infrared spectrum to uncover the chemical makeup of exoplanet atmospheres, searching for signs of water vapor or organic molecules. Meanwhile, missions like NASA's Perseverance rover on Mars are drilling into ancient lake beds, hunting for fossilized evidence of microbial life that might have existed billions of years ago. These endeavors, grounded in planetary science facts, are not just about finding life. They're about understanding the conditions that make it possible, conditions we take for granted on Earth. Imagine the day when a signal, perhaps from a distant world like TRAPPIST-1e, reveals a spectrum of life indicating gases. How would that change your perspective on our place in the universe? Even closer to home, scientists are studying Earth's own extremes, deep-sea vents and acidic lakes, to model how life might survive on alien worlds with radically different environments. This research, blending biology and astronomy, shows us that life might not look like us at all. It could thrive in ways we can't yet imagine. The implications are staggering. If life is more adaptable than we think, the universe might be teeming with hidden ecosystems. This thought bridges us to a broader horizon, our responsibility as stewards of Earth while we reach for the stars. Every mission, every discovery, is a step toward answering the ultimate question of whether we're alone, and it's a journey that unites us as a species. As we near the end of this exploration, let's hold on to this sense of shared purpose, this drive to know more, and channel it into a commitment to both protect our planet and continue our cosmic search with unwavering curiosity. As our journey to the center of the Earth and beyond comes to a gentle close, let's anchor ourselves in the awe and responsibility that this exploration inspires. We've traveled 4,000 miles beneath our feet to the molten heart of our world, and we've soared across light years to ponder exoplanet mysteries and the fragile dance of habitability. Earth, with its unique blend of conditions, stands as a beacon in the cosmic wonder of the universe, a reminder of what we have and what we might find. But this story is far from over. It's a living narrative that you, dear listener, are a part of. I encourage you to dive deeper into planetary science facts, to read about the latest discoveries from missions like the James Webb Space Telescope, and to let your curiosity guide you. What questions linger in your mind about our place among the stars? How can we better protect this fragile home while searching for others? Share your thoughts in the comments below. I'm eager to hear your reflections and ideas. If this immersive journey has sparked something in you, please give this video a like. Subscribe to Earth with Nature for more explorations into the wonders of our universe, and hit the notification bell so you never miss an adventure. Together, let's build a community of curious minds, united by a passion for discovery and a love for the only home we know. As we part ways for now, carry this sense of wonder with you, and remember, whether Earth is one of many worlds or a solitary miracle, its beauty and mystery are ours to cherish and explore. Until next time, keep looking up, keep questioning, and keep connecting with the vast, incredible universe that surrounds us. Thank you for joining me on this profound journey. Let's continue our exploration by delving deeper into the restless nature of Earth's surface, a phenomenon known as plate tectonics. which shapes our world in ways that might echo across other planets in the realm of cosmic wonder. Beneath our feet, the Earth's crust is fragmented into massive plates that float on the semi-fluid mantle, grinding against each other over millions of years to form mountains, trigger earthquakes, and carve out ocean basins. This dynamic process, driven by the heat from the planet's core we discussed earlier, is a key reason why Earth remains habitable. It recycles carbon through volcanic activity, stabilizing our climate over eons. But imagine this. Could similar tectonic dances occur on distant exoplanets? Planetary science facts suggest that worlds with liquid interiors, like Jupiter's moon Europa with its subsurface ocean, might exhibit their own version of geological activity, reshaping surfaces and perhaps nurturing life in hidden depths. Consider the implications. If tectonics or analogous processes are common, could they be a universal marker of habitability? I invite you to ponder. How might the slow, grinding motion of Earth's plates mirror the unseen forces shaping alien landscapes? As we study exoplanet mysteries through missions like the upcoming Plato telescope, set to launch by the European Space Agency, we're on the cusp of detecting subtle signs of geological activity on distant worlds by analyzing their surface compositions. This connection between Earth's restless crust and the potential for life elsewhere stirs a sense of awe. Our planet's very restlessness might be a clue to finding others like it. Let's hold this thought as we transition to an even broader canvas, exploring how the chemistry of life on Earth might hint at universal patterns across the stars, deepening our emotional and intellectual bond with the cosmos. As we build on the idea of Earth's unique dynamics, let's turn our gaze to the building blocks of life itself: carbon, hydrogen, oxygen, and nitrogen, and ask whether these elements form a universal blueprint for existence. Here on Earth, life as we know it relies on water as a solvent and carbon as a structural backbone, enabling the complex molecules that define biology. But planetary science facts challenge us to think beyond our biases. Could silicon-based life thrive in the searing heat of a distant world, or might exotic chemistries emerge in the methane lakes of Saturn's moon Titan? Scientists are recreating alien environments in laboratories, using simulations to test how life might adapt to conditions vastly different from ours, revealing that the universe could be far more creative than we imagine. Picture a world where life doesn't breathe oxygen but thrives on sulfur or ammonia. How would that reshape our definition of habitability? Reflect for a moment. Are we limited by our Earth-centric view? Or is there a deeper universal chemistry waiting to be uncovered? The search for exoplanet mysteries pushes us to analyze atmospheric spectra for unexpected chemical signatures, using tools like the Hubble Space Telescope's successor, the James Webb, to detect anomalies that could hint at alien biology. This quest isn't just scientific. It's deeply personal, stirring a sense of connection to a universe that might be teeming with life in forms we can't yet fathom. As we marvel at Earth's chemical elegance, we're reminded of its fragility, a delicate balance that might be rare or replicated countless times across the cosmos. Let's carry this curiosity forward as we explore how time itself, through the lens of deep history, shapes the story of planets, both ours and those yet to be discovered. Now let's stretch our minds across the vast expanse of deep time, the billions of years that have sculpted Earth into the living world we know, and consider how this temporal journey might parallel the evolution of other planets. Earth's history spans 4.5 billion years, from a molten, lifeless sphere bombarded by asteroids to a planet blooming with ecosystems after the emergence of single-celled organisms around 3.5 billion years ago. Each era, the formation of oceans, the rise of oxygen through photosynthesis, the mass extinctions, marks a chapter in a saga of resilience and change. But what of other worlds caught in their own timelines? Planetary science facts, drawn from studies of Mars' ancient riverbeds and Venus' thick, toxic atmosphere, suggest that many planets undergo dramatic transformations over eons, sometimes losing their potential for life. Could an exoplanet in the habitable zone of its star be in its own infancy, awaiting the spark of biology, or might it be a relic of a once thriving biosphere? Pause and think. How does the immense scale of time shape your view of Earth's journey compared to unseen worlds? Missions like the Mars Sample Return, planned by NASA and ESA, aim to bring back rocks that could reveal whether life ever existed there, offering a glimpse into a planet's past. This exploration of deep time in the realm of cosmic wonder evokes a profound humility. Earth's story is but one thread in a tapestry of planetary histories, each unfolding at its own pace. As we reflect on this, let's shift toward the technological frontiers that allow us to peer into these ancient narratives, connecting Earth's past with the potential futures of distant stars. Building on the concept of deep time, let's marvel at the technological frontiers that empower us to read the ancient stories etched into planetary surfaces, both here and far beyond. Spectroscopy, a technique that analyzes light to reveal a planet's chemical makeup, has become a cornerstone of modern astronomy, allowing us to study Earth's geological record and extend that knowledge to exoplanets. For instance, by examining light reflected from distant worlds, the upcoming Large UV/Optical/IR Surveyor, LUVOIR, telescope concept could detect signs of past geological or biological activity, much like how we've mapped Earth's history through rock layers. On our own planet, robotic explorers like the Curiosity rover on Mars drill into sediment, uncovering clues about ancient climates, while oceanographic drones probe Earth's deep-sea trenches for extremophiles, organisms that thrive in conditions mirroring alien environments. Imagine the thrill of decoding a signal from an exoplanet that hints at a billion-year-old biosphere. How would that reshape our understanding of life's persistence? I ask you to consider, what technological breakthrough do you think will finally unveil the secrets of another world? These advancements in planetary science facts are not just tools. They're bridges to the unknown, linking Earth's narrative to the exoplanet mysteries we yearn to solve. Each discovery fuels an emotional investment in our shared cosmic journey, reminding us that technology is an extension of human wonder. Let's hold this sense of progress as we transition to the ethical dimensions of our search, pondering what finding another habitable world, or failing to, means for our responsibility to Earth and beyond. As we push the boundaries of technology to uncover distant worlds, let's also grapple with the ethical dimensions of this search, a realm where science meets morality in the vast arena of cosmic wonder. If we confirm life on an exoplanet, even microbial, what obligations do we have to protect it from contamination by our probes, as outlined in planetary protection protocols by organizations like COSPER? Earth's own history of colonization and environmental harm serves as a cautionary tale. How do we ensure we don't repeat those mistakes on a cosmic scale? Conversely, if we find countless barren worlds, does that heighten our duty to preserve Earth as the only known cradle of life? Reflect on this. How should humanity balance exploration with stewardship, both here and in the stars? The search for exoplanet mysteries isn't just about discovery. It's about defining who we are as a species. Projects like the Breakthrough Starshot Initiative, aiming to send tiny probes to Proxima Centauri, raise questions about the risks and rewards of interstellar outreach. Could we inadvertently harm or be harmed by what we find? These ethical dilemmas, grounded in planetary science facts, stir a deep sense of responsibility, urging us to tread lightly as we extend our reach. They also connect us emotionally to Earth, a fragile oasis we must safeguard while we dream of others. As we near the close of this extended exploration, let's channel these reflections into a renewed commitment to curiosity and care, preparing to wrap up with a vision of unity in our cosmic quest. Finally, as we draw this extended journey through Earth's depths and the universe's expanse to a close, let's envision a future where our search for other worlds unites us in purpose and wonder. Every layer of Earth we've explored, from its molten core to its life-giving chemistry, mirrors the potential stories of countless exoplanets waiting to be understood. Whether we're decoding planetary science facts through advanced telescopes or pondering the ethical weight of our discoveries, this quest transcends borders, cultures, and generations. It's a shared human endeavor. Imagine a day when we confirm another habitable world, not as a distant dream but as a catalyst for global cooperation, inspiring us to protect our own planet with renewed vigor. Or consider the silence of the cosmos as a call to cherish Earth even more deeply. What vision of the future does this cosmic wonder inspire in you? I invite you to share your hopes and ideas in the comments, to continue this dialogue about exoplanet mysteries and our place among the stars. If this extended exploration has ignited your curiosity, please like this video, subscribe to Earth with Nature for more thought-provoking content, and ring the notification bell to stay part of our growing community. Together, let's keep asking the big questions, nurturing our connection to this remarkable planet while reaching for the unknown. Thank you for staying with me on this profound continuation of our journey. May your sense of awe and responsibility guide you until we meet again to explore the next chapter of the universe's endless story.